You guys are doing 2.4. Complex numbers. So your I can statement up there is I can solve problems with complex numbers, which you've probably never heard of. I don't think you have. All numbers are actually complex. But before we talk about what a complex number is, we need to talk about the imaginary unit, I. It's really called I. Can you take the square root of -9? Can. You can push buttons in a calculator, what would it say? Error. It would say error what? Got it. I don't know. Grab a calculator, see what it says. Try typing in square root of -9 in a calculator. See what it says. I'm sorry. Error, not really. A lot of kids are already giving it away, but I literally want you to see what your calculator says if you ask it what the square root of -9 is. What are you doing? What did it say? Non-real. Error, non-real. AKA imaginary, right? So in order to be able to take the square root of -9, we have to introduce this concept. And these are on your formula quizzes. Anybody know how we define I? Square root of what? -1. I is the square root of -1. Plain and simple, that's what she is. And there's more to it than that, but that's just what the imaginary unit is. So if I want to know what the square root of -9 was, what I would do is I would view it as the square root of -1 times the square root of 9. What is the square root of 9? 3. It's 3. And what do I now know is defined to be the square root of -1? I. It's right there, kids. You can take the square root of negatives, but they are what? Imaginary. Hence the letter I. Okay? Complex number has two parts. It has a real part plus an imaginary part. The real part is usually called the letter A. The imaginary part is BI. That's what a complex number is. And all numbers are complex. Even the number 2 is complex. Because it can be written as 2 plus how much I. Zero. All numbers are complex. Two plus 0i only has a real part. But it can be written as a complex number, can't it? Four minus 2i has a real part and an imaginary part. No longer the item, but 0 minus I. That doesn't have a real part, but it has an imaginary part, but it can be written in the form a plus bi. Every number that exists is complex. Every single one of them. All right, here we have the idea of what's called the complex conjugates. Conjugates would be something fairly new to y'all, but not really. Let's see if you remember something from Algebra 1. Conjugate of 2 minus root 3. Anybody remember what the conjugate of 2 minus root 3 is from Algebra 1? Bunch of nopes. All right, conjugate of 2 minus root 3 is 2 plus root 3. What changed signs? Radical change sign. Works the same way with complex conjugates. If A plus BI conjugate is A minus BI. It's kind of a big deal. Imaginary numbers, when you have solutions, always happen in conjugate pairs. All imaginary solutions happen in conjugate pairs. I should be saying complex. All complex solutions happen in conjugate pairs. And again, I know it's going to be hard for you to believe, but without this math, lights go out. That thing that you zombie into 8 hours a day doesn't exist. Solutions or soul system, whatever you want. The abbreviation too, SOL, you know what that means. Yeah, let's do some examples. 4 minus 2i. What's its conjugate? What's the conjugate of 4 minus 2i? 4 plus 2i. Really that simple. Let's try negative 3 plus 2i. Negative 3 minus 2i. Do something silly like positive 4i. What's its conjugate? Negative 4i. If you're just now tuning in, it's all about this line right here. What changes sign? The real piece or the imaginary piece? Imaginary piece. That's all you do from conjugate. It's not a hard skill. It is easily forgotten though. All right, so that was just notes. I think we can do a little math on the next page. I think the next page is about talking about solving by square rooting. It is. Not everything should be factored. That could be factored, couldn't it? This could be x squared minus 16 is 0. That factor is x minus 4 and x plus 4. Then you could use zero product property and have your solutions. But did it need to be done that way? There's a square root method which you use if you can easily take the square root of both sides. What's the square root of x squared? X. What's the square root of 16 since you're solving for x? Plus or minus. That was x squared, by the way. That 2 up top says 2 solutions. You don't include the plus or minus, you missed half the question, and according to the meme board, you killed a baby panda. Back there, I promise you. There's a meme about that, about killing pandas. And they're already extinct, or not extinct, endangered. Don't kill any more of them. If you forget plus or minus, baby panda dies. Now, was that solution real? Is 4 real? Is negative 4 real? Yes. So it was just a warm up to remind you of something you could have done in the past. The next one, a little bit different. Can you still use the square root method? You can. You have something squared on the left. You can square both sides. What's the square root of x? Squared x. Now, square root of negative 9 is worth talking about. I can break that in to the square root of negative 1 times the square root of 9. It can be broken apart. Second period acted like they'd never seen break apart rules like that. but second grade doesn't know much, to be quite honest. You all had Miss Garner. At some point in time, Miss Garner did things like breaking apart radicals, like root 21 could be root 7 times root 3, couldn't it?
Yeah.
That shouldn't be a new skill.
We did a little bit of it in the calculus as well.
You're supposed to do it in 8th grade, 9th grade, 10th grade, 11th grade, possibly 12th, depending on the class you take. Anyways, why would I break it apart like this? What's special about that? Look back at your notes. That is a definition. It's I. I is the square root of -1. So I can be thinking about this as I times the actual positive root of 9. And what is the actual root of 9? 3. Now, we don't write this I3, we write it 3I. And do we like pandas?
No.
How many solutions is it supposed to have?
So plus or minus.
Plus or minus. Plus or minus thrice I. Don't write I3. This is not an iPhone from the early 2000s. Okay. It's 3I. Any issues? What's I again?
-1. Square root.
Square root of -1. All right, here's our try it. What should we take of both sides? Square root. Is that going to be real or imaginary? Here's what I would do. The first thing I would do is I would change the number to be positive and put it right out front. Does that make any sense? Should. Need a note, write a note. It's negative, put an I out front, drop the sign. Plain and simple. Now also in your 8th, 9th, and 10th grade years, they taught you the process of simplifying radicals. Can you take the square root of 72? It doesn't exist, doesn't have one. But I'll give you a little side example here. Maybe root 24. Root 24 can be rewritten as root 4 times 6. Because 4 times 6 is 24. And what's the square root of 4? 2. When you do the same simplification with root 72. So I need factors of 72, one of which I can take the square root of.
8 and 8 now.
Ah, it's the second one today. No, I'm going to explore it because it needs to be explored. So Kai says root 8 times 9. One of those pieces you can take the square root of. Which one is it? It becomes 3 root 8. It has been simplified, but this is like simplifying 4 over 20 as 2 over 10 and being done with it. You can do 4 and 2.
36.
And what's the square root of 4? 2. That goes out front. 2 times 3 root 2. 6 root 2. That's at least the thought process that has to go on your head. Multi-step. How well do kids do with multi-step crap? Not good. So the correct thing to do is think of the correct pair of factors right from the get-go.
36 and 2.
36 and 2. By the way, I like pandas, plus or minus. I'm not saying you can't get the right answer to this path. It takes longer. Plus, it gets a little more confusing to some kids. What's the root of 36? 6. If you don't know that, try memorizing your squares. 6i root 2. Do not write I6 root 2. Don't do it. You get judged.
So we wouldn't put the I behind the square root of 2.
Sometimes they do that. We usually, when it's typed, you'll see it quite often. We'll do this 6 root 2 I. But when it's written, nobody does. The reason being is when it's typed, you know for sure where the square root symbol stops. I mean, people are lazy when they write. They might write that. I would. That make any sense? If you type it, you'll usually see the I afterwards, but if it's written, it's always before.
Okay.
I'm old school. Everything I ever did was written, so I put it where it belongs up front. If I type it, I still put it there usually. All right, any questions on this? I think what's up next in your notes is probably adding and subtracting. Yes. What is the sum of -4 minus 7i and -11 plus 9i? The number of kids that will miss questions like this blows my mind. At some point in time in high school, somebody has asked you to do something like this. 4 plus 3x plus, I don't know, maybe -5 minus 2x. What do you do in that situation? What do you add? Like terms. That's all you do. So this would be -1, what, plus x?
Yeah.
Or maybe x minus 1? Have you write it? Is this going to be any different? Are you going to see the I and freak out? Probably. Some kids will. Some kids think it changes everything. Is sum. Sum means do what? Add. So what is 4 plus a -11? And then -7i plus positive 9i. Just group like terms and add them, please.
-7 plus 2.
-7 plus 2i. That's addition. I think there's even a hint down there. Combine real parts and imaginary parts as you would combine like terms. Your TI-84s can do this too. It's worth talking about. When you do your homework, I don't want you actually pushing buttons, but if you need to check on some of the harder stuff, by all means check. There she is. What was the original question? 4 minus 7i. So parentheses 4 minus 7. If you look at your faceplate and look at the decimal key, what do you see in blue? I. So 4 minus 7, it's second decimal. There's I. Close the parentheses, it was sum, so plus -11 plus 9, second decimal. There you go. It can do quite a bit of the imaginary math, but it cannot take square roots of negatives for you. It does have an I key on it. I would like to get through subtraction today at least. This one is subtraction because it says difference. I would say probably 1 in 2 people miss these, at least the first time. They may not know what difference is. You see a lot of kids actually do the double distributive problem because they can't read or don't want to read, 1 and 2. But what do you think the common mistake is? They don't distribute the negative. The common mistake on these is kids do not use the distributive property. They just look at the numbers as they are. But they're like distributive property. Never heard of her. All right, that's where we stop. See y'all tomorrow. I'm done missing school until at least mid-April. Sorry about your luck.